Hey there, welcome. Today, we're going to pull back the curtain on something we all use every single day, but maybe don't totally understand: the internet itself. We're going to demystify the complex, invisible journey your data takes across the entire globe in the blink of an eye. So let's trace that secret journey step by step.
I mean, it seems so simple, doesn't it? You type in a website, hit enter, and poof, it just appears. But what is actually happening under the hood? It's a fascinating, high-speed chain reaction that makes our entire digital world possible. So let's dive in and unravel that mystery together.
Okay, to really get a grip on this, we're going to use one simple analogy for this whole explainer. Just think of every single thing you do online as sending a super secure package across the globe. From getting the address right, to choosing the fastest route, to making absolutely sure no one can peek inside, it's all part of this incredible, invisible logistics system.
So first things first, any good courier service needs a rulebook, right? A set of standards everyone agrees to follow? Well, for the internet, that rulebook is called the TCP/IP model. You can think of it as a four-layer framework that makes sure your digital package is packed up, shipped out, and received perfectly, no matter where in the world it's going.
All right, so our courier's ready to go. But before they can deliver anything, they need one absolutely critical piece of information: the exact address of where it's going. See, you know the website's name, but computers, they don't. They speak a different language, the language of numbers. So the big question is, how does your browser turn that friendly website name into the string of numbers it really needs?
Well, that's where the domain name system, or DNS, comes into play. Seriously, the best way to think about it is as the internet's massive global address book. You give it a name you can remember, like a website, and it instantly looks up the corresponding number, the IP address, that computers actually need to talk to each other. But here's the cool part. It's not just a simple one-step lookup. It's this super clever hierarchical journey. Your computer first asks a local server. If that server doesn't know, it asks one of the main root servers for the whole internet. The root server doesn't know the exact address, but it knows who to ask next, like the server in charge of all the .com addresses. That server then points you to the final, authoritative server that has the exact address you need. It's this brilliant cascade that can find any address on the planet in milliseconds. Now, speaking of these addresses, we're actually in the middle of a huge upgrade. The old system, IPv4, was kind of like a gumball machine. It seemed like a lot at first, but its 4.3 billion addresses have pretty much run out. The new system, IPv6, on the other hand, it's like the entire night sky, a virtually infinite number of addresses. But even more importantly, it's not just about more space. It was built from the ground up with better security baked right in.
Okay, so we've got the address. Awesome. Now we have to make a choice. How are we going to send this package? Is it something that absolutely, positively has to get there with the signature confirmation? Or is it more important that it just gets there as fast as humanly possible, even if, a tiny piece gets lost?
And this is where we have to choose between two main delivery options: TCP and UDP. So TCP is your certified mail. It's super reliable. It actually establishes a connection, kind of like making a phone call, and it checks that every single piece of data arrives in the perfect order. That's why your emails and web pages always load correctly. Then you've got UDP, which is more like standard mail. It just blasts the data out as fast as it can. It's way quicker, which is perfect for things like video streaming or online gaming, where a single dropped pixel is a small price to pay to avoid that dreaded lag. So here's something that might surprise you. Our internet courier doesn't just take the most direct line on a map. No way. It's much smarter than that. It uses a massive global web of infrastructure to find the absolute most efficient route, dodging digital traffic jams to make sure your data arrives at lightning speed. And one of its best tricks is to not even send the package from far away in the first place.
And one of the most brilliant pieces of this smart infrastructure is the CDN, or Content Delivery Network. Just picture a network of local warehouses or fulfillment centers. Instead of shipping a website's images all the way from a single server across the world, a CDN stores copies on servers that are physically close to you. This cuts down the travel time, what we call latency, so dramatically that the website feels like it loads almost instantly.
Okay, so along this super fast route, our data also meets these gatekeepers called proxies. Now, a forward proxy sits in front of you, the user, maybe to hide your location or get around some network rules. But the real powerhouse here is the reverse proxy. It sits in front of the web servers themselves. It's like a bouncer, a traffic cop, and a personal assistant all rolled into one. It balances all the incoming requests, it speeds things up, and it protects the important back-end servers from all the chaos of the open internet.
Okay, quick recap. Our package has an address, a delivery method, and a super fast route. We're almost there. But what about privacy? How do we make sure that while our package is zipping across the world, nobody can just rip it open and read what's inside? Well, this is where encryption comes in.
So the first way we can do this is with something called symmetric encryption. This is kind of like having a lockbox where you and the person you're sending it to have the exact same physical key. It's incredibly fast to lock and unlock the box, but it has one big problem. How do you get that single key safely to the other person without someone intercepting it?
And that's the exact problem that asymmetric encryption solves. This is more like having a public mailbox. Anyone in the world can use your public address to drop a letter in the slot. That's the public key. But only you, with your special private key, can actually open the mailbox and read the letters. It's an amazing way to establish trust. But there's a catch. It's a lot slower.
So you might be thinking, do we have to choose between security and speed? Nope. Modern secure connections, like the little lock icon you see in your browser, do something absolutely brilliant. It's called the SSL/TLS handshake. First, they use the slow but super secure asymmetric method, just long enough to safely create and exchange a brand new secret key just for this one conversation. Then, once that's done, they switch to the super fast symmetric method to send all the actual data. It's a beautiful solution that gives us the best of both worlds. All right, so let's zoom out for a second and put all of these pieces together. Because these aren't just some abstract concepts, They are the literal blueprints for how we build the massive, reliable, and scalable systems that we all depend on every single day.
And a perfect example of all this in action is something called an API gateway. It acts as the single main front door for a really complex application. It takes all the things we've been talking about, smart routing, security, traffic management, and it applies them at one critical choke point, orchestrating all the requests across dozens or even hundreds of smaller services that are working away behind the scenes.
So what's the big takeaway here? Why does any of this actually matter to you? Because understanding these fundamentals is what lets you make smart design choices. Knowing about CDNs and UDP means you can build faster, more responsive experiences for your users. Understanding HTTPS lets you create applications that people can actually trust with their data. Using reverse proxies and gateways helps you design systems that can scale up to millions of users. This isn't just theory. This is the language of modern system design.
So there you have it. We started with a simple question: what happens when you press enter? And we've ended up with the entire blueprint for the internet's rules of the road. But these aren't just rules to memorize. They're tools. They're the building blocks you can use to create the next generation of fast, secure, and amazing applications. The only real question left is, now that you know the rules, what are you going to build?